Again, in this video, we're going to look at the graphs of derivatives. And let's start with example 4. We're given the graph of some function f of x, and what we want to do is graph the derivative of this function. And here's how we're going to do it. Remember, the derivative evaluated at a point gives you the slope of the tangent line at that point. So let's say you want to find the derivative at -5, right? F prime evaluated at -5. Well, that's the slope of the tangent line at -5. So if we can figure out the slope of this tangent line, that's f prime of -5. Well, the slope of this tangent line right here, notice that for every one you run, you actually drop 1 unit. So your rise is -1. So if you said rise over run, you would get -1 over 1. And so this has a slope of -1. This tangent line does. So that means f prime evaluated at -5 is equal to -1. But that's true at every single point over here below -2. Notice at -3, f prime of -3 is also -1 because the slope of this tangent line is still -1. And so that's true for every single point for every x value below -2. So if you were to graph that, you would get a horizontal line at -1 for all the x values in here. So that's the graph of the derivative of this function. Remember, the graph of the derivative, the y value represents the slope of the tangent lines for the x values in here. Okay, now, once you get into here, x values in here, the tangent line is different. So let's say you want to find f prime at -1, right? Well, that's the slope of the tangent line at -1, and the slope of this tangent line appears to be 1. For every one you run, you rise 1. Okay, and that's true for every point in here. Okay, so if you were to graph the derivative in here, you're going to get a horizontal line at 1. So it's going to look like this. Again, this represents the y value here, represents the slope of the tangent lines in here. Okay, and now let's look at the x values on the other side in here when you're above 0, when x is above 0. Okay, so you move over here and look at the tangent lines over here. So let's just go to, let's say, 2, x equals 2. So f prime evaluated at 2 would be the slope of this tangent line at 2. Okay, so the slope, okay, looks like for every 2 that I run, I actually rise by -1. I drop 1. So the rise is -1 and the run is 2. So the slope is -1/2. And that's true for every x value over here. The slope of the tangent line for every x value over here is -1/2. And so if you're going to graph the derivative on this side, you're just going to get a y value of -1/2. It's a horizontal line at y equals -1/2. Okay, for all the x values above 0. Now notice that f prime of -2, there is no ordered pair for that. And that's because f prime at -2 is undefined. And the reason it's undefined is because there isn't a tangent line at -2. And the reason there's not a tangent line at -2 is because if you look at the secant lines on the left-hand side of -2, so let's approach -2 from the left. So let's say you draw a secant line between -3 and -2. The secant line on this side has a slope of -1. In fact, every secant line on this side has a slope of -1. So as you approach -2, all the secant lines have slopes of -1. And so they're approaching the tangent line. So apparently the tangent line on this side has a slope of -1. But notice if you approach from the other side and you draw secant lines on this side, the secant lines on this side have a slope of +1. And as you get closer and closer to -2, every one of these secant lines has a slope of +1. And so the slopes of those secant lines are approaching 1. And so the slope of the tangent line on this side is also 1. And so in order for the slope of the tangent line to exist at this point, you must approach the same number from both sides. Okay, but you're not. From the left-hand side, you're approaching -1, and from the right-hand side, you're approaching +1. And so the tangent line, the slope of the tangent line itself does not exist at this point, but neither does the slope of the tangent line, because there is no line. Okay, that's why f prime evaluated at -2 does not exist. And so this is true for any sharp corner that you come to, any sharp point that you come to. The tangent line does not exist at that sharp point. And that's also true at this sharp point. The secant lines on this side are all have a positive slope of +1, and then all the secant lines on this side have a slope of -1/2. And so they're not approaching the same number. The secant lines on this side are approaching 1, and the secant lines on this side are approaching -1/2. And therefore, the slope of the tangent line at this point doesn't exist. Okay, so f prime evaluated at 0 does not exist. And so that's why we have an open circle at those two x values. Okay, so that's how we graph the derivative of a function. Okay, so let's look at this one. So this is the graph of g of x, and we want to graph its derivative. So one thing we can do to make our life a little bit easier is let's find first the location where the derivative is equal to 0. And that's at any spot where the tangent line is horizontal, which will be at these 3 spots. Since the tangent line is horizontal, the slopes of the tangent lines would be 0, right, when the tangent line is horizontal. So g prime of -3 is 0, g prime at -1 is 0, and g prime at 1 is 0. And so if you plot these, right, because we're going to graph the derivative, g prime, then -3, when x is -3, I get a y value of 0. So this ordered pair is at -3, 0, right there. And that's an x-intercept. This one's -1, 0, another x-intercept. This one is 1, 0, another x-intercept. So you're getting the x-intercepts when the slope of the tangent line is 0. Okay, so that's why this is nice. If you find all the horizontal tangent lines, you're actually finding the places where you have x-intercepts for your derivative. Okay, now let's try to fill in the rest of this. So let's look at some x values below -3 and see what the slopes of the tangent lines look like. So initially, look at the slope of the tangent line over here. It looks to be very positive. But as you continue on, I think you can see that it becomes less positive. Okay, and so we're going to draw the derivative here. The derivative is in red, right? G prime is in red. So it starts off really positive, and then notice it's dropping because the tangent lines, the slopes of the tangent lines are becoming less and less positive. Now, at some point, the slope of the tangent line is going to be 0 because it becomes horizontal, and you can see that the derivative, the graph of the derivative is dropping down towards this point right here, where the slope of the tangent line is 0. So less and less positive, and then right at -3, the derivative is 0. But then on the other side of this, when x is -3, you can see that the slopes become negative, and they're becoming more and more negative in here. And that's why the derivative is now below the x-axis. But at some point, it's going to get as negative as it's going to be. Look at the slopes of the tangent lines right now. It's about as negative as it's going to get. And that's why the graph of the derivative is going to become less and less negative. It's going to start, the y values in here are going to become less and less negative because the slopes of these tangent lines are becoming less and less negative. And then eventually it's going to be 0. Okay, so it's less and less negative. And then right at -1, the tangent line becomes horizontal. And so the derivative is 0, and that's why it's crossing the x-axis. And then on the other side of -1, the slopes of these tangent lines are starting to become positive, and that's why the derivative, the graph of the derivative, is above the x-axis. Okay, and so in a very similar way, at some point, the slope of that tangent line is going to be as positive as it's going to get. And so the graph of the derivative is going to start dropping once that happens. Okay, so I think it's roughly in here somewhere. Okay, so it's about as positive as it's going to get. And then notice that the slopes of these tangent lines are going to start leveling off towards 0, and that's why the graph of the derivative is less positive. And you can see it's dropping, the graph is dropping towards 0, the x-intercept. Okay, and then once you get to that point, of course, the derivative is 0 because of horizontal tangent line at 1. And then from there, you can see the slopes of those tangent lines are negative, and they just become more and more negative, and therefore the graph of the derivative just continues to head towards negative infinity. Okay, so that's how we graph the derivative of a function. If I give you the graph of some function, and you want to graph the derivative of that function, then what you really need to do is look at the slopes of the tangent lines at every point for this function. And that way you can graph the derivative, because the derivative would be the slopes of the tangent lines at those various points. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.